What if the universe had a rule, a law so fundamental, so absolute that it governed the very flow of time and the nature of reality itself, a law etched into the fabric of space-time, a commandment stating, "Thou shalt not travel faster than light"? For over a century, this has been the bedrock of our understanding the ultimate speed limit imposed not by technology but by existence. Every experiment we have ever conducted, every observation we have made has reinforced this cosmic decree. It is the anchor that prevents the paradoxes of causality, the guardrail that keeps the universe sane. And yet out there in the howling wilderness between galaxies we have seen it. We have photographed the impossible. A celestial storm, a torrent of incandescent gas caught in a cosmic hurricane, is streaking across the void at a speed that defies comprehension. It's a river of fire flowing through the heavens, a glowing filament that appears to be moving not just at the speed of light, but at 5, 10, sometimes even 50 times that ultimate velocity. This isn't a theoretical quirk or a mathematical ghost. It is a direct observation captured by our most powerful telescopes which link continents together to form an eye the size of a planet. The data is unambiguous. The images are stark. Before our very eyes, matter is seemingly shattering Einstein's sacred law. It's a paradox of such profound magnitude that it forces us to question everything. Have we been fundamentally wrong about the universe? Is the theory that has guided us through the cosmos for 100 years, the theory of relativity, incomplete, or even worse, broken? Or are we witnessing something far stranger? An illusion so perfect, so mind-bending, that the truth it hides is even more astonishing than the violation it suggests. This is the story of that illusion of a journey into the heart of the most violent engines in the cosmos, to solve the mystery of the cosmic hurricane that moves faster than light. To grasp the sheer audacity of what we are seeing, you first have to understand the sanctity of the law being broken. It is the pillar upon which modern physics rests. Before the dawn of the 20th century, our concept of the universe of Isaac Newton, was a place of absolutes. Space was a rigid, unchanging stage, a cosmic grid. Time was a universal clock ticking at the same rate for everyone everywhere. An hour on Earth was an hour on Jupiter, and an hour in the Andromeda galaxy. It was simple, intuitive, and as it turned out, profoundly wrong. The revolution began not in a laboratory, but inside the mind of a young patent clerk in Bern, Switzerland. Albert Einstein, through a series of brilliant thought experiments, dared to ask a child's question. With a genius's insight, what would you see if you could ride on a beam of light? The answer to that deceptively simple question unraveled reality. Newton's universe couldn't accommodate such a journey. The laws of electricity and magnetism which governed light predicted that its speed was constant, always the same, regardless of how fast you were moving when you measured it. This was a deep and troubling contradiction. If you're driving down a highway at 50 miles per hour and throw a ball forward at 10 miles per hour, an observer on the roadside sees the ball moving at 60. Speeds add up, but with light this simple logic failed. If you're in a rocket travelling at half the speed of light and you turn on a flashlight, that beam of light doesn't move at 1.5 times light speed. It moves at exactly the speed of light. The universe, it seemed, was conspiring to keep this one speed sacred. Einstein realized that for this to be true, something else, something we thought was absolute, had to give. That something was space and time itself. He saw that they were not separate and rigid, but interwoven, a single dynamic fabric he called space-time. And this fabric could stretch and shrink. The faster you move through space, the slower you move through time. Your personal clock begins to tick more slowly than for a stationary observer. Your ruler in the direction of the motion begins to shrink. These effects are imperceptible at everyday speeds, but as you approach the velocity of light, they become dramatic, catastrophic. Time for you would slow to a near standstill. Your mass would increase towards infinity. Pushing you to the speed of light would require an infinite amount of energy, more energy, than exists in the entire observable universe. The speed of light, therefore, is not just a speed, it is a boundary, a fundamental asymptote built into the geometry of space-time. It is the speed of causality itself. Think of it this way: if you could send a signal faster than light, you could send a message back in time. You could tell your grandfather not to meet your grandmother, creating a paradox that would unravel the logical consistency of the universe. The cosmos protects itself from this temporal chaos with this one simple rule. Absolutely nothing with mass can reach the speed of light, and no information of any kind can travel faster. This principle, born from a thought experiment, has been tested and confirmed to an astonishing degree of precision, from GPS satellites that must account for relativistic time dilation to particle accelerators that slam protons together at 99% of light speed. Relativity has passed every test we've thrown at it. It is the language we use to speak to the cosmos, which makes the images scrolling across our screens all the more terrifying, because those images tell us that a jet of superheated plasma, billions of times more massive than our Sun, is flagrantly violating this most fundamental of cosmic laws. It is a ghost in the machine of physics and observation that screams heresy. So where do we find these impossible spectacles? They don't happen in quiet, suburban, spiral galaxies like our own Milky Way. To witness such cosmic defiance, you have to travel to the most violent and energetic places the universe has to offer, the galactic core. Look toward the centre of almost any large galaxy, our own included, and you will find a monster lurking in the dark. A supermassive black hole, a gravitational titan millions or even billions of times more massive than our Sun. For a long time we pictured these objects as passive cosmic vacuum cleaners simply swallowing anything that strayed too close. But we now know that they are the most powerful engines of creation and destruction in the known universe. They are the dynamos that can power a quasar, a celestial object so luminous it can outshine its entire host galaxy of hundreds of billions of stars. The process begins with a feast. As gas dust and entire stars are pulled into the black hole's grasp, they don't fall straight in. Instead, they are caught in a gravitational maelstrom, forming a vast, flat, swirling structure called an accretion disk. This is not a gentle whirlpool. It is a cosmic blender of unimaginable scale and violence. Friction within this disk, as matter spirals towards its doom, heats the material to millions, even billions of degrees. It glows with an intensity that is difficult to fathom, a celestial furnace, where the laws of physics are pushed to their absolute limits. The entire disk becomes a seething inferno of plasma, crushed and superheated by the black hole's relentless gravity. But not all of this material is consumed. The black hole is paradoxically a messy eater. In a process, we are still struggling to fully understand the immense rotational energy of the black hole, combined with the incomprehensibly powerful magnetic fields generated by the accretion disk, creates a cosmic escape valve. A fraction of this in falling superheated matter is captured by these magnetic fields, twisted into a vortex, and then ejected away from the black hole in two colossal tightly focused beams. These are relativistic jets. They are twin blowtorches erupting from the poles of the black hole, firing in opposite directions perpendicular to the accretion disk. They are fountains of plasma stellar material accelerated to velocities so extreme they are a significant fraction of the speed of light. These jets can be immense, stretching for hundreds of thousands, even millions of light-years far beyond the confines of their parent galaxy, ploughing through the tenuous intergalactic medium like a battering ram. They are cosmic particle accelerators built by nature on a scale that dwarfs anything humanity could ever hope to construct. And it is within these jets, these incandescent spears of matter hurled across the cosmos, that we find our crime scene. To see them, astronomers had to invent a new kind of eye. A single telescope, no matter how large, lacks the resolution, the sharpness of vision to distinguish details inside these distant jets. It would be like trying to read the headline on a newspaper in London while standing in New York. So they pioneered a technique called Very Long Baseline Interferometry, or VLBI. Instead of one giant dish, they use an array of radio telescopes spread across continents, all synchronized by atomic clocks of incredible precision. From Hawaii to Germany, from Chile to the Arctic, these telescopes stare at the same target at the exact same moment. By combining the data from all of them, a feat of supercomputing and signal processing, they can synthesize a virtual telescope with a diameter nearly as large as the Earth itself. This global eye gives us the power to see the unseeable, to resolve the fine structure within these cosmic hurricanes. It allows us to watch individual knots and blobs of glowing plasma as they are blasted out from the central engine. We can track their movement over months and years, measuring their progress against the backdrop of more distant stationary stars. The technique is flawless. The measurements are precise, and the results are insane. Year after year, as we watch a blob of plasma move, we can calculate its sideways velocity across the sky. Knowing the distance to the galaxy, simple trigonometry should tell us its true speed. But the numbers that come back from the calculations are impossible. The first time it was definitively measured in the quasar 3C273, the result was a shock wave that rippled through the astronomical community. A glowing knot of gas was clocked at nearly 10 times the speed of light. It wasn't a one-time error. As our techniques improved, we found more, many more. Galaxies like 3C120 and BL Lacertae and a host of others all showed features within their jets that were painting streaks across the sky at speeds that made a mockery of Einstein's most cherished principle. We called it apparent superluminal motion, a cautious scientific name for something that felt like a profound break in the cosmic order. The evidence was mounting, undeniable and persistent. The photograph of the impossible was not a smudge on the lens. It was a real feature of the universe. Herein lies the grand paradox that drives our investigation. On one hand, we have the entire edifice of 20th century physics, a theory of relativity tested and proven in countless ways that states with absolute certainty that the speed of light is an unbreakable barrier. It is the very foundation of our understanding of cause and effect. On the other hand, we have a clear, direct, repeatable observation from our most advanced instruments, showing matter traversing the cosmos at multiples of that speed. One of them must be wrong. So what are we to believe, our theories or our eyes? Is it possible that in the crucible of a quasar's heart, where gravitational and magnetic forces reach levels of extremity that we can barely simulate, some new undiscovered physics comes into play? A loophole in relativity that only opens up under such duress? If so, the implications are staggering. It would mean our understanding of the universe is not just incomplete, but has been missing a chapter of unimaginable importance. It would open the door to possibilities that have until now been confined to the realm of science fiction. Or perhaps the truth is more subtle and yet no less profound. Perhaps the laws of physics are not being broken at all. Perhaps what we are seeing is not a physical object shattering a cosmic law, but light itself playing a trick on us. A trick of geometry and time, a grand celestial illusion created by the very nature of light and the unique perspective from which we observe these jets. An illusion so perfect it can fool our most sophisticated instruments and challenge our most fundamental assumptions about reality. The solution to the mystery of the cosmic hurricane, it turns out, is not hidden in new physics, but in a deeper appreciation of the physics we already have. It's a revelation that forces us to see the universe not just as a collection of objects, but as a dynamic interplay of space-time motion and perception. To unravel this spectacular cosmic magic trick, we must now journey deep inside one of these relativistic jets. We must ride along with a beam of light as it travels for millions of years, racing against the very plasma that it illuminates. We will have to untangle the strange ways that time and distance can conspire to deceive us when objects are moving at nearly the speed of light and heading almost directly towards us. The answer is waiting for us, hidden in plain sight, within the elegant equations of Einstein himself. The hurricane is not what it seems. It is not a violation of reality, but a window into its deepest and most counterintuitive truths. The paradox is not a failure of our science, but an invitation to see the universe with new eyes, to understand the subtle, intricate dance of light and time across the grandest of cosmic stages. The storm is real, but its impossible speed is a magnificent phantom, and the story it tells is more wondrous than any simple breach of natural law. What if the silence of space was a lie? For millennia we listened with our eyes charting a cosmos of serene predictable light. A clockwork of stars and planets moving to silent gravitational rhythms. But in the mid-20th century we built new ears, vast metal dishes tuned not to light but to a hidden spectrum of radio waves. And when we turned them to the heavens, we discovered the universe wasn't silent at all. It was screaming. Amidst the gentle hiss of our own galaxy, there were points of unimaginable noise. Piercing shrieks in the radio spectrum coming from sources so compact they looked like single unassuming stars. At first, they were mere curiosities, entries in a catalogue of cosmic static. 3C273, 3C48, dry technical names for what would become the greatest cosmic puzzle of the age. Astronomers trained their optical telescopes on these locations, and what they found only deepened the confusion. They saw faint bluish points of light masquerading as stars in our own Milky Way. But these were no ordinary stars. Their light, when split into its constituent colours, revealed a chemical fingerprint that made no sense. A chaotic jumble of spectral lines that corresponded to no known element, no familiar stellar process. For years, these cosmic enigmas were orphans of astronomy, their true nature, a complete and maddening mystery. They were dubbed quasi-stellar radio sources, a name that was little more than a confession of ignorance. Quasars. The breakthrough came not with a thunderclap, but with the quiet contemplation of a man staring at a photographic plate. In 1963, astronomer Martin Schmidt, working at the legendary Palomar Observatory, had a flash of insight that would forever alter our perception of the cosmos. Staring at the bizarre alien spectrum of 3C273, he decided to entertain a wild, almost heretical idea. What if the pattern wasn't alien at all? What if it was a familiar pattern, the simple signature of hydrogen but distorted beyond all recognition? He imagined taking that familiar fingerprint and stretching it, pulling the lines far, far towards the red end of the spectrum. Suddenly the chaotic jumble snapped into perfect focus. The lines matched, the code was broken, but the implications were terrifying. This colossal redshift was the universe's own speedometer. It was the telltale sign of an object hurtling away from us at a tremendous velocity carried on the expanding fabric of space-time itself. And for an object to be receding that quickly, it had to be fantastically mind-bogglingly far away. Not a local star a few thousand light-years from Earth, but a resident of the deepest, most remote abyss of the cosmos. 3C273 wasn't next door. It was over 2 billion light-years away. A phantom from a time when our own solar system was nothing but a cold, spinning cloud of dust and gas. The discovery was a triumph, but it immediately presented a paradox so profound it threatened to break physics. If you know how far away a light is, you can calculate its true intrinsic brightness. We do it with light bulbs, with stars, and now with this quasar. And the number the mathematics spat out was impossible. It was absurd. 3C273 was not just bright, it was blazing with the light of 2 trillion suns. It was a single point in the sky that was outshining our entire Milky Way galaxy by a factor of 100. Imagine a single bonfire on a distant hill, somehow brighter than all the cities of a continent combined. What celestial engine could possibly generate that much power? What physical process could unleash such a torrent of energy from a region of space that from our perspective was no bigger than a pinprick? The hunt was on for a monster. No single star, no cluster of stars, not even a supernova. The most violent explosion we knew could account for such a sustained gargantuan output. The answer had to be something new, something extreme, something that dwelled in the realm of theory, a concept born from Einstein's equations that was so strange even he had trouble accepting it. The answer was a black hole. But not just any black hole, the kind formed from a dying star. This required a different class of beast entirely. A supermassive black hole, a gravitational titan, a singularity containing the mass of millions or even billions of our Sun, compacted into a space smaller than our solar system. These behemoths we now believe are the dark hearts of almost every large galaxy, including our own. They are the cosmic anchors around which everything else dutifully orbits. For most of their lives, they are dormant sleeping giants consuming only the occasional star that wanders too close. But in the young chaotic universe, galaxies were awash in gas and dust. Food was plentiful, and when a supermassive black hole begins to feed, it does not do so quietly. It ignites, transforming into the most luminous object in the universe. It becomes a quasar. You must picture the scene. A vast, swirling disk of matter hundreds of billions of miles across forms around the black hole's equator. It is a cosmic whirlpool, an accretion disk composed of shredded stars, vanquished gas clouds, and pulverized asteroids. This is not a gentle orbital dance. It is a maelstrom of unimaginable violence. As this material spirals inward toward the event horizon, the point of no return, it is subjected to the most extreme forces in nature. The black hole's gravity compresses it, while intense friction between the spiraling layers of gas heats it to temperatures of millions of degrees. The substance of the disk ceases to be mere gas. It becomes a superheated plasma, a searing torrent of charged particles trapped in a gravitational death spiral. This cosmic grinding mill, this vortex of incandescent matter, is the true engine of the quasar. The black hole itself is dark, a perfect abyss. But the disk surrounding it burns with a ferocity that defies description. It unleashes a flood of radiation across the entire electromagnetic spectrum, from low-energy radio waves to the most energetic deadly gamma rays. It is this light born from the death throes of matter that travels across billions of light-years of expanding space to reach our telescopes. The faint, unassuming blue star that so puzzled astronomers was, in fact, the glare from a cosmic bonfire of apocalyptic proportions, a celestial lighthouse signalling from the dawn of time. We were not seeing the monster itself, but the brilliant scream of its last meal. Yet this infernal accretion disk is only half of the story. The process that generates this incredible light also creates something else, something even more spectacular and far more mysterious. As the plasma swirls at velocities approaching the speed of light, it drags and twists the powerful magnetic fields that are threaded throughout the disk. Near the black hole's poles, where the gravitational pressure is slightly lessened, these magnetic fields become wound into colossal, tightly coiled towers. They become a cosmic dynamo, a particle accelerator of galactic proportions. This system, a spinning black hole and its magnetic dynamo, is capable of a final stunning act of creation amidst the destruction. It can grab a fraction of the infalling superheated plasma from the very inner edge of the accretion disk, and defying the black hole's own immense gravity, redirect it. This matter is funneled through the magnetic towers and ejected outwards away from the black hole in two perfectly collimated needle-thin beams. These are the relativistic jets. They are not merely streams of gas. They are lances of pure energy, celestial blowtorches punching their way out of the host galaxy and into the void of intergalactic space. The particles within these jets are accelerated to more than 99.9% of the speed of light. They are some of the fastest moving macroscopic objects in the entire universe. The scale of these structures is staggering. While the quasar's central engine might be contained within a region the size of a solar system, its jets can travel for hundreds of thousands, sometimes millions of light-years. They are vastly larger than the very galaxies that give them birth. As they plough through the cosmos, they glow with an ethereal light, their charged particles spiraling around magnetic field lines and emitting a ghostly radio hum. This is the noise, the radio scream, that first alerted us to the quasar's existence. The twin beams, often beautifully symmetric, are a testament to the fundamental physics at play, a display of raw power that can shape the evolution of everything around them. These cosmic fire hoses can inflate giant lobes of plasma trigger shockwaves that ignite furious bursts of star formation in nearby clouds of gas, or conversely blast a young galaxy clear of its star-forming fuel, effectively sterilizing it for eons. They are the visible manifestation of the supermassive black hole's influence, its reach, extending far beyond the grasp of its gravity. The discovery of this complete system, the supermassive black hole, the brilliant accretion disk, and the colossal relativistic jets, was a landmark achievement. It solved the great paradox of the quasar's impossible brightness, and painted a new dynamic picture of a young and violent universe sculpted by forces we had never before imagined. We had found the monster, and we thought understood its weapons. A feeding black hole, a brilliant disk, and two jets of plasma firing into the darkness at the ultimate cosmic speed limit, the speed of light. A beautiful, terrifying, and complete model. For a time, it seemed we had wrestled this cosmic enigma into submission, explained its impossible power with the elegant but extreme physics of Einstein. We had a blueprint for the most powerful engines in the cosmos. But the universe is rarely so simple. And just as we began to grow comfortable with our understanding of these cosmic hurricanes, the jets, these pillars of plasma travelling at the very edge of possibility, did something that made no sense at all. They appeared to break the one inviolable law of the cosmos, They appeared to move faster than light. The work itself was meant to be an exercise in cosmic patience, a slow, methodical charting of the heavens. For decades, we had known of these incandescent points of light, these quasars burning with the fury of 1 trillion suns from the edge of the observable universe. But knowing they existed was one thing. Understanding the titanic engines powering them was another entirely. Our instruments, newly sharpened by the advent of radio astronomy, were finally powerful enough to resolve not just the blinding core, but the faint ethereal structures extending from them, the jets. These were the exhaust plumes of the cosmic engine, stupendous columns of energized matter hurled into the void. To map them was to map the anatomy of a monster. And so astronomers at observatories from California to Australia settled in for the long watch. They focused on one of the brightest and most famous of these celestial lighthouses, a beacon in the constellation Virgo known as 3C273. The process was painstaking, a throwback to an older era of astronomy. Huge, delicate photographic plates were exposed for hours, capturing the faint photon spray from a source over 2 billion light-years away. Night after night, month after month, year after year, the images were collected, catalogued and filed away. Each plate was a single frame in what they hoped would become the slowest, most distant motion picture ever created. They were looking for change, for any sign of evolution in this colossal structure. Perhaps a slight dimming, a subtle shift in colour, or a gentle, stately expansion over the course of a decade. The universe at these scales was assumed to move with a glacial, almost imperceptible grace. What they found instead would shatter that assumption and threaten to break physics itself. The first hints were subtle, easily dismissed as flaws. On a plate from 1966, a small bright knot of plasma was visible within the jet. On another, from a few months later, that same knot seemed displaced. It was a statistical ghost, an artifact of the atmosphere, a cosmic ray strike on the emulsion. It had to be. The alternative was simply unthinkable. But the pattern persisted. With each new plate, the luminous blob marched further away from the quasar's core. It wasn't a subtle drift, it was a sprint. An astronomer perhaps late one night, deep in the archives, would have overlaid the plates one on top of the other. They would have expected the stars to align perfectly fixed points of reference in the celestial sphere, and they did. But against that static backdrop, the smudge in the jet of 3C273 had moved. It had moved an impossible distance. The time came to do the math. It was a simple calculation, the kind of trigonometry you learn in high school, but applied across a chasm of space and time that defies human comprehension. You know the distance to the object, a staggering 2.4 billion light-years. You can measure the apparent angle of the blob's movement across the sky from the photographic plates, a tiny fraction of a degree. With these two figures you can calculate the physical distance the blob has travelled. Then you divide that distance by the time elapsed between the photographs. The result is its speed. The scientists who first performed this calculation must have stared at their notes in utter disbelief. They must have checked their figures again, and then a third time convinced a decimal point had been misplaced, or a unit of measurement mistranslated. The numbers were lying. They had to be. Because the answer that stared back at them from the page was not just fast. It wasn't just a new cosmic speed record. It was a violation. The calculations showed the blob of plasma was moving at nearly 10 times the speed of light. 9.6 c to be precise. Almost 3 million kilometers per second. It was like watching a car on a distant highway and calculating its speed to be faster than the light from its own headlights. It was a result that didn't just challenge the consensus. It held a dagger to the heart of Albert Einstein's special theory of relativity. For over half a century, one principle had served as the bedrock of our understanding of the universe, that the speed of light in a vacuum is the absolute unbreakable speed limit. Nothing, no object, no information, no causal influence can travel faster. It is the fundamental constant that stitches the fabric of space-time together. And yet here was a photograph, a piece of hard empirical evidence that seemed to show this law being flagrantly, spectacularly broken. The discovery sent a shockwave of frantic disbelief through the astronomical community. The initial reaction was not excitement, but a deep professional skepticism, even fear. Announcing such a result was to paint a target on your back. To claim you have overturned Einstein is an extraordinary act demanding proof, so rigorous, so utterly beyond reproach that no other explanation is possible. So they searched for errors. Every conceivable flaw in the chain of logic was mercilessly scrutinized. Could the distance to 3C 273 be wrong? This was the first and most obvious suspect. If the quasar were much, much closer than believed, the calculated speed would drop accordingly. For decades, the very nature of quasars had been debated. Perhaps they weren't distant cosmological objects at all, but smaller, stranger bodies ejected from our own galaxy. This local quasar hypothesis was a fringe theory, but the superluminal motion gave it a sudden, desperate appeal. If 3C 273 was only a few million light-years away instead of a few billion, the problem would simply vanish. The blob's speed would become comfortably subsonic, a mere puff of smoke. But the evidence for the vast distances to quasars was overwhelming. Their light is profoundly redshifted, stretched to longer, redder wavelengths by the expansion of the universe itself. This cosmic redshift is our standard ruler for measuring deep space. To deny the distance to 3C 273 was to deny the expansion of the universe, the very foundation of modern cosmology. It was an attempt to solve one paradox by creating a far greater one. It was trading a broken law of physics for a broken universe. The idea was quickly and decisively abandoned. The quasar was exactly as far away as we thought. The problem remained. What else could it be? Perhaps the error lay not in the heavens but in the telescope. Was it an optical illusion, a distortion created by the Earth's atmosphere, or the instrument's own lenses? Teams at different observatories using entirely different telescopes and techniques turned their gaze toward the quasar. They used the new technology of Very Long Baseline Interferometry, or VLBI. This revolutionary technique links radio telescopes thousands of miles apart, synchronizing them with atomic clocks, to create a single virtual telescope the size of the Earth. The resolution was astonishing, capable of seeing a football on the surface of the Moon. If the superluminal motion was a mere artifact of single-dish telescopes, VLBI would reveal the truth. The first VLBI maps of 3C 273 came back not with a refutation, but with a stunning confirmation. The resolution was now so sharp that astronomers could see not just one blob, but a whole chain of them being fired from the quasar's core like luminous cannonballs. And each one of them was racing outwards at impossible speeds. The phenomenon was real. It wasn't an error. It wasn't a smudge on a plate. It was happening. The crisis deepened. The focus of the debate shifted from denying the observation to trying desperately to explain it. The scientific journals of the era became a battleground of bizarre and brilliant ideas. Could it be that the laws of physics themselves were different in the hearts of quasars? Perhaps in these extreme environments where gravity crushes matter to unimaginable densities, Einstein's writ simply did not run. This was a tantalizing but dangerous thought. Science prefers universal laws. A law that changes from place to place isn't much of a law at all. Others proposed even more exotic solutions. Could we be seeing a kind of searchlight effect? Imagine a lighthouse beam sweeping across a distant cloud bank. The spot of light on the clouds could easily appear to move faster than light, but nothing is actually travelling from one point on the cloud to another. It's just the intersection point of the beam. Perhaps the quasar jet was not a stream of matter, but some kind of sweeping energy beam exciting stationary gas as it passed. This was a clever idea, but it failed to match the details. The blobs of plasma had their own distinct identity. They cooled and dimmed as they moved exactly as you would expect a real physical cloud of hot gas to do. They weren't just ephemeral spots of light. They were objects. They had substance. The tension in the field was palpable. At conferences, astronomers would present their latest, ever more precise measurements of these cosmic fugitives. The speeds were not just a little over the limit. They were ludicrously so. A quasar named 3C 279 was found to have a jet component moving at over 17 times the speed of light. Another BL Lacertae clocked in at 7 times light speed. This wasn't a singular freak of nature. It was a common feature of these powerful objects. It was as if we had discovered an entire ecosystem of animals that could fly without wings. The universe was taunting us with a trick it refused to explain. You could feel the intellectual vertigo setting in. Physicists had built a beautiful, elegant cathedral of understanding based on the primacy of the cosmic speed limit. Now it seemed as though distant quasars were throwing stones through its stained glass windows. Every attempt to find a conventional explanation failed. The observations were solid, the distance measurements were secure, the physics was apparently broken. We were staring at evidence that told us two contradictory things at once. First, that a cloud of plasma had travelled from point A to point B. Second, that it had done so in less time than light itself would take to make the journey. This is a paradox of the highest order. It means that if you were sitting at point B, you could see the blob arrive before you saw the light from its departure at point A. It scrambles the fundamental relationship between cause and effect. It allows the future to influence the past. The implications were not just astronomical, they were philosophical. The very logic of reality seemed to be at stake, all because of a few tiny moving smudges of light on a photographic plate. For a time, there was a genuine sense that we had stumbled upon a crack in the foundations of reality, a glimpse of new physics that would force us to rewrite the textbooks. The excitement was matched only by the profound confusion. How could this be? How could matter organized and coherent be propelled to speeds that were not just a fantasy of science fiction, but a mathematical impossibility? The universe was presenting us with an exquisite, maddening puzzle. It had laid out all the pieces on the table, the quasar, the jet, the impossible motion. But the image they were supposed to form seemed to make no sense. It was a picture of a square circle of a silent scream. There had to be an answer, a perspective we were missing that could reconcile the irrefutable evidence with the unbreakable law. The very integrity of the scientific endeavour depended on it. But as the 1970s wore on, with more and more examples of superluminal motion being added to the catalogue, that answer remained stubbornly out of reach. We were cosmic detectives standing at a crime scene where the culprit had left footprints that moved faster than time itself, and the only witness was the silent, indifferent light from the beginning of the world. The confrontation had begun, but the truth was still hiding, cloaked in the geometry of space-time itself. And so we were left staring into an abyss of our own making. An observation that defied a century of established physics, a cosmic hurricane whose winds appeared to shred the very fabric of causality. The data streams were unambiguous, the calculations checked and rechecked by minds across the globe. Gas hurled from the heart of a galactic monster was charting a course across the void at 7 times the speed of light, an impossible velocity. A flagrant violation of the universe's most sacred law, the cosmic speed limit Einstein etched into the bedrock of reality. It was a moment of crisis, a schism between what we saw with our own eyes and what we knew fundamentally to be true. When faced with such a profound contradiction, science does not simply surrender. It searches for a hidden door, a deeper layer of truth that resolves the paradox not by breaking the rules, but by revealing our own misunderstanding of the game. The universe we were about to learn is not always what it seems. It is a grand illusionist, and its most breathtaking trick was about to be unveiled. The key, the elegant secret that would mend this schism in our understanding, was not hidden in some exotic new physics, but in a subtle yet profound misinterpretation of the scene playing out across millions of light years. We had been behaving like a spectator at a magic show focused on the grand gesture, while missing the sleight of hand. The problem wasn't with the speed of the gas itself, but with the geometry of our observation, a trick of perspective so extreme it could fool light itself. The first clue lay in the sheer, unholy brightness of the jet. It didn't just glow, it blazed with a ferocity that seemed disproportionate to its size, a celestial blowtorch aimed directly into the eye of the cosmos. This intense luminosity was not a coincidence. It was the first breadcrumb on a trail leading out of the paradoxical woods, a sign that we were not merely passive observers of this event. We were in a very real sense staring down the barrel of a cosmic gun. This phenomenon is known as relativistic beaming, and it is one of the most dramatic consequences of travelling near the speed of light. Imagine an object at rest emitting light equally in all directions, like a simple lantern hanging in the darkness. Now accelerate that lantern to a significant fraction of light speed, something extraordinary happens. The light it emits becomes concentrated, focused into a brilliant narrow cone pointing in its direction of travel. It is no longer a lantern. It has become a searchlight, a piercing relativistic spotlight. The faster it moves, the tighter and more intense that cone of light becomes. For the material in this cosmic jet screaming through space at over 99% of light speed, virtually all of its energy, its radiation, its titanic fury, is funneled into an incredibly fine, forward-facing beam. This explains the jet's impossible brilliance. We are seeing it not because it is simply bright, but because by sheer cosmic chance the Earth, our solar system, our entire civilization, happens to be positioned almost perfectly in the path of this extraordinary beam. We are looking directly into the heart of the furnace. This realization is both terrifying and illuminating. It means that for every one of these blazers we see shining so brightly there could be hundreds, even thousands of others racing through the cosmos unseen. Their beams are aimed just a few degrees away from us, their incredible light sweeping past our galaxy like a lighthouse beam sweeping over an empty patch of ocean. We are witness to this spectacle only because of a fluke of celestial alignment, a 1 in 1,000 shot across an unimaginable distance. But this beaming, this intense focusing of light is only the first part of the illusion. It explains the why so bright question, but it doesn't yet solve the why so fast paradox. For that we must venture deeper into this hall of cosmic mirrors and confront the way our own perception of time and space is warped by the geometry of light itself. The true deception is not just in what we see, but in when we see it. To understand this grandest of cosmic illusions, we must recalibrate our intuition. Let's leave the galactic core for a moment and imagine something more familiar. A speedboat racing across a lake heading almost directly towards you as you stand on the shore. The boat is moving fast, but it's also at a very slight angle, so you can see it moving sideways away from a stationary buoy. Now imagine the driver of the boat throws a ball into the water at the start of its run, and then 1 minute later throws a second ball. From your perspective on the shore, what do you see? You see the splash of the first ball, then you wait. But you don't wait the full minute to see the second splash. Why? Because in that minute the boat has dramatically closed the distance between itself and you. The light the image of that second splash has a much shorter journey to your eyes than the light from the first. If the boat were travelling fast enough, perhaps the second splash might appear to you only a few seconds after the first, even though the events themselves were a full minute apart. Now apply this principle to the cosmic jet. Instead of a boat, we have a knot of superheated plasma, a plasmoid ejected from the black hole's accretion disk. Instead of a buoy, we have the black hole itself, our stationary reference point. And instead of travelling at 100 kilometers an hour, this plasmoid is moving at more than 297,000 kilometers per second, almost the speed of light. It is racing nearly but not quite directly towards Earth. Let's say we take a picture of it at year 0. The light from that event begins its long journey towards us across millions of light years. Now let's say 10 actual years pass. In that decade, the plasmoid travelling at 99.5% the speed of light has moved 9.95 light years closer to us. It emits another burst of light, and that new light begins its journey. Here is the heart of the illusion. The light from the second event, the year 10 event, has a 9.95 light-year head start on the light from the year 0 event. It is chasing the first pulse of light through space, relentlessly closing the gap. From our vantage point on Earth, millions of years later, the first pulse of light finally arrives. We see the plasmoid at its starting position, then we wait for the second pulse. But we don't have to wait 10 years. Because the second pulse had that colossal head start, it arrives just a short time after the first one. For a jet moving at this specific speed and angle, the light from an event that happened 10 years later might arrive just 6 months after the light from the first event. Our telescope records 2 images separated by only 6 months of our time. But in those images we see the plasmoid has moved a measurable distance sideways across the sky. Its sideways motion, what astronomers call its proper motion, is real. The illusion is in the timing. We see 10 years of sideways travel squeezed into what our clocks measure as only 6 months. And what is speed? It is simply distance divided by time. We are seeing a real distance, but we are dividing it by an artificially compressed illusory time. The result is an apparent speed that is not just high, it's impossible. A phantom velocity born from a geometric trick of light and time. This is the projection effect. It's a temporal mirage. We are witnessing a kind of cosmic accordion, where a decade of events is squeezed into a few months of observation, all because the source is moving towards us so fast that it's nearly keeping pace with the very light it emits. The message in a bottle is almost catching up to the wave it was launched on. When you combine this temporal distortion with the sheer intensity of relativistic beaming, the full picture of the cosmic hurricane snaps into focus with breathtaking clarity. It's a perfect storm of relativistic phenomena. The jet must be travelling at a very specific, incredibly high velocity, somewhere in the rarefied air above 99% of light speed. It must be oriented at a very precise, very small angle, relative to our line of sight not perfectly at us, or we'd see no sideways motion at all, but not too far to the side or the illusion wouldn't work. When these exacting conditions are met, the universe puts on its magic show. The laws of physics are not broken, they are in fact the very engine of the deception. The superluminal motion is not real, but the physics that creates its appearance is profoundly real, a stunning confirmation of Einstein's special relativity pushed to its absolute limits. The moment this solution crystallized in the minds of astrophysicists was a watershed. The crisis resolved into a revelation. The feeling was not one of disappointment that something wasn't truly breaking the light-speed barrier, but of awe at the elegance and subtlety of the cosmos. The universe wasn't broken, our perspective was simply too limited. This paradox, which had seemed poised to shatter our understanding of physics, was instead transformed into a powerful new diagnostic tool. Suddenly, the illusion itself became the source of information. By measuring the apparent superluminal speed of a jet, and by analysing the characteristics of its beamed radiation, we can work backwards. We can use the very mathematics of the illusion to calculate the jet's true speed, a value impossibly difficult to measure directly. We can determine its precise angle to our line of sight, mapping the three-dimensional structure of these cosmic fire hoses. We can deduce the raw power of the central engine the black hole required to accelerate matter to these unfathomable velocities. The ghost in the machine of space-time had become our guide. This dramatic shift in understanding rippled through astronomy. What was once a baffling anomaly became a signature, a telltale sign of a black hole engine of immense power, oriented in just the right way. We began searching for more of these phantoms, and we found them. Scattered across the sky were dozens of these superluminal sources, each a testament to this beautiful geometric deception. Each one is a cosmic laboratory, where we can test the limits of physics under conditions of gravity and velocity that we can never hope to replicate here on Earth. They are beacons not just of light, but of knowledge, shining a relativistically beamed spotlight on the most extreme environments the universe has to offer. They taught us that to truly comprehend the cosmos, we must be prepared to question our own senses, to accept that the universe can play tricks on us that are so profound, so convincing, they appear to rewrite the laws of reality itself. We had looked into the eye of the hurricane and found not chaos but an intricate, elegant and perfectly structured illusion. The paradox was solved. But in its place, a new set of questions began to bloom, questions no less profound. We now understood the how of this magnificent spectacle, the physics behind the curtain. But what of the what? What is this material that can withstand being accelerated to within a hair's breadth of the ultimate cosmic speed limit? What forces are at play in the heart of that galactic nucleus? A gravitational gyroscope spinning up matter and flinging it across intergalactic space. And perhaps most chillingly, what would it mean to be a civilization not just looking down the barrel of this cosmic jet, but to be a world, a solar system directly and completely in its path? Having unmasked the illusionist, we now find ourselves compelled to understand the nature of its fire, to move from the geometry of the spectacle to the raw, physical reality of the hurricane itself. The magic trick has been explained, but the monster at the heart of it remains waiting for its own story to be told. So the illusion is broken. The cosmic ghost, the phantom of faster-than-light travel, has been unmasked for what it is: a trick of perspective, a grand celestial sleight of hand, But to solve one puzzle is merely to unlock the door to a far deeper, far more violent mystery. Knowing how. The light deceives our eyes, tells us nothing of the fury that generates the light in the first place. The real question, the one that shakes the foundations of astrophysics, has been waiting patiently behind the curtain of geometry. What kind of engine, what concentration of raw power could possibly forge a weapon capable of firing matter across a galaxy at nearly the speed of a light? What is the anatomy of this cosmic hurricane? The answer takes us to the most extreme environment we have ever dared to imagine, to the very precipice of a supermassive black hole. We must descend into the maelstrom. Here at the heart of an active galaxy, gravity is no longer a gentle force that holds planets in their orbits. It is a ravenous tyrant. In a region smaller than our solar system, a monster sleeps a singularity with the mass of billions of suns, and it is feeding. A vast luminous whirlpool of doomed matter, the accretion disk spins around the abyss. This is the black hole's larder, a reservoir of gas dust and shredded stars, all spiralling toward their final moment. But this is no quiet, orderly descent. It is a cosmic traffic jam of unimaginable violence. As matter crowds inward, friction and tidal forces ignite a celestial inferno. The disk becomes a plasma, an incandescent soup of charged particles heated to millions, even billions of degrees hotter than the core of our own sun. It glows with an intensity that can outshine all the 100 billion stars of its host galaxy combined. This is the blinding glare that so often hides the central engine from our view. It's a place where the fabric of space-time itself is being twisted, where the sheer density of energy warps the laws of physics into new and terrifying shapes. For decades we believed this was a one-way street, as a place where matter only checks in. Yet we see the evidence screaming across the cosmos from the heart of this ultimate destination. Something is escaping. Not just escaping, but being violently, catastrophically ejected. Gravity alone, even the supreme gravity of a black hole, cannot explain this paradox. To understand how a black hole can both devour and expel, we must look beyond gravity. We must visualize an invisible architecture, a force that gives structure to the chaos. We must see the magnetic fields. The churning, superheated plasma of the accretion disk is a perfect electrical conductor. As this sea of charged particles orbits the black hole at relativistic speeds, it acts as the universe's most powerful dynamo. It generates magnetic fields of staggering strength, 1 billion times more powerful than the field that shields our own planet. These fields are not static. They are rooted in the disk, dragged along by its ferocious rotation and twisted into a frenzy. Imagine threads being spun from a cosmic spindle. The rotation of the disk, and crucially the spin of the black hole itself, begins to wind these magnetic field lines into tight helical towers that extend vertically away from the disk's plane. They become magnetic funnels, 2 colossal vortices pointing away from the black hole's poles. The plasma, being composed of charged particles, is now a prisoner of this magnetic topology. It can no longer just slide sideways into the black hole. It is compelled to follow these spiraling magnetic pathways. The black hole and its disk have woven a cage, a magnetic prison, and now they are beginning to squeeze. This is the genesis of collimation, the process that takes a chaotic swirling disk and forges its fury into a pair of focused needle-thin beams. The magnetic fields act as a cosmic nozzle, a focusing mechanism of exquisite power and precision. But focusing the material is only the first step. The true miracle, the source of the jet's terrifying velocity, is the conversion of raw magnetic energy into pure kinetic motion. The tightly wound, twisted coils of the magnetic field are like a spring being compressed to its absolute limit. Stored within this magnetic structure is an immense reservoir of potential energy, an energy drawn directly from the rotational momentum of the black hole itself. The spinning singularity is not just a gravitational anchor, it is a colossal flywheel, a storehouse of power accumulated over eons. The magnetic fields tap into this rotational energy, slowing the black hole's spin by an infinitesimal amount and siphoning off that power. Then the spring is released. In a process we are only just beginning to model with our supercomputers, this stored magnetic tension uncoils with explosive force. It creates a vast electromagnetic accelerator, along the black hole's axis of rotation. Charged particles trapped within the funnel are seized by this expanding field and flung outwards. They are propelled along a magnetic rifle barrel that spans light years, accelerated relentlessly until their velocity pushes ever closer to the ultimate cosmic speed limit. This is not a single explosion like a supernova. It is a continuous sustained blast, a celestial blowtorch that can operate for millions of years, powered by the black hole's spin and the steady rain of matter from the accretion disk. The hurricane is not just born of chaos. It is meticulously engineered by the fundamental forces of the universe. The sheer scale of the energy budget is difficult for the human mind to contain. The power radiated by a single one of these jets can exceed the total light output of our entire Milky Way galaxy by a factor of 1,000. To put that in perspective, imagine the combined energy of 100 billion suns focused into a beam narrower than a light year and fired across the void. The energy released by our sun over its entire 10 billion year lifespan would power one of these jets for less than a minute. This is the power of mass-energy conversion at its most efficient. While a star's fusion engine converts less than 1% of its fuel's mass into energy, the black hole's accretion engine can convert 10, 20, even up to 40% of the mass of infalling matter directly into the raw power of the jet. It is the most efficient engine known to exist in the cosmos, and its exhaust is a river of fire that reshapes galaxies. What then is this river made of? What is the substance of the cosmic hurricane? When we analyze the light from these jets, we find the spectral fingerprints of a truly exotic fluid. It is a plasma, but not like any found on Earth. It's a relativistic soup primarily of electrons and their antimatter counterparts, positrons forged in the crucible of the accretion disk where gamma rays can spontaneously convert into particle-antiparticle pairs. These particles are so energetic that their individual mass is almost irrelevant. What matters is their collective momentum. They flow not as a simple gas, but as a fluid governed by the strange and beautiful laws of magnetohydrodynamics, where the interplay between moving charges and magnetic fields dictates every eddy and swirl. Within this seemingly smooth beam, immense turbulence rages. As faster-moving pockets of plasma overtake slower ones, they create shock waves that propagate through the jet. These are not sound waves, but colossal electromagnetic disruptions, cosmic sonic booms. At these shock fronts, particles are accelerated, yet again slammed into even higher energies. They are forced to radiate away that energy as synchrotron radiation, a ghostly light that allows our radio telescopes to trace the jet's path across intergalactic space. The bright knots and hotspots we observe within the jets are not clumps of matter in the conventional sense. They are the visible scars of these internal collisions, fleeting signposts, marking regions of extreme particle acceleration, glowing for a few thousand years before fading back into the flow. The jet is not a solid object, but a dynamic, ever-changing torrent of energy and matter, constantly renewing itself from the central engine. For the longest time, we viewed these jets as mere curiosities, spectacular, but isolated footnotes in the story of the universe. We were wrong. We now understand that you cannot comprehend the life of a galaxy without understanding the influence of its central black hole. These jets are not footnotes. They are fundamental architects of galactic evolution. They are the feedback mechanism, the regulatory system that connects the impossibly small scale of the black hole's event horizon to the impossibly large scale of the galaxy itself. As a jet erupts from the galactic core, it does not travel through empty space. It plows through the galaxy's own tenuous atmosphere, the vast cold reservoir of hydrogen gas that is the raw fuel for creating new stars. This is where the jet becomes a galactic thermostat. With immense kinetic force, it slams into these clouds of gas, heating them to millions of degrees and blasting them out of the galaxy entirely. This is known as negative feedback. The jet effectively clears the cupboards, starving the galaxy of the material it needs to continue building stars. It is a form of self-regulation. If a galaxy grows too quickly, it funnels more gas toward its central black hole. This in turn fuels a more powerful jet, which then erupts and quenches star formation, slowing the galaxy's growth. This cosmic balancing act may be the primary reason we see a limit to how large galaxies can get. The hurricane at the center prevents the city of stars around it from growing uncontrollably, ensuring a form of galactic equilibrium over billions of years. It is an act of majestic, sweeping destruction that is essential for cosmic order. But the universe is rarely so simple. The story of the jets is a profound paradox, for these agents of galactic sterilization can also be the harbingers of creation. As the jet's powerful shockwave expands outwards, it doesn't always expel the gas. Sometimes it merely compresses it. Imagine a wave of pressure, a cosmic snowplow sweeping through the interstellar medium. This compression can be the precise trigger needed to cause vast clouds of gas to collapse under their own gravity, igniting a furious burst of new star formation in their wake. We have seen this happening. Along the path of these relativistic jets, we observe stellar nurseries lines of brilliant young blue stars tracing the shock front like lights on a runway. The very same hurricane that can choke a galaxy to death can in other circumstances seed it with new life. It is a stunning realization. The life and death of stars in the tranquil outer arms of a galaxy can be directly dictated by a process occurring in a tiny region, at its very heart, an event that happened millions of years before. The jet is both the sculptor's chisel and the farmer's plough. It carves out vast cavities in the galactic gas, and it tills the cosmic soil to prepare it for new growth. This dual role reveals an intricate web of connection that spans a galaxy, a delicate dance between creation and destruction, orchestrated by the monster at its core. The hurricane is not just a feature of the galaxy. It is a force that actively defines what the galaxy is and what it will become. It is the ghost in the machine, the unseen hand that guides the evolution of cosmic structure on the grandest possible scale. We have journeyed from a simple optical illusion to the very engine room of the cosmos. We have unmasked the black hole not as a mere gravitational sink, but as a dynamic powerhouse. We have traced the invisible architecture of magnetic fields that shape and fire these jets across the heavens, and we have witnessed their profound galaxy-altering impact. Yet for all we have deduced, a deep and frustrating veil remains. Our understanding is built on inference, on observing the aftermath. We see the majestic radio lobes painted across the sky, the glowing scars left by the jet's passage. But the launch site itself, the critical region just a few light hours across where the plasma is gripped, twisted and thrown into the void, remains almost entirely hidden from our view. It is shrouded by the incandescent glare of the accretion disk and obscured by immense distances. How can we ever hope to pierce that veil? How can we directly witness the birth of the hurricane? To see the magnetic fields in the act of collimation, to watch the conversion of rotational energy into a relativistic outflow, would be to solve one of the greatest remaining puzzles in astrophysics. To do so would require a telescope not the size of a mountain, but the size of a planet. It would demand that we find a way to achieve an observational focus so sharp it could see a crater on the moon from here on Earth. An impossible dream, perhaps? Or perhaps it is the very next step in our cosmic journey, a challenge that is already being met by a new generation of explorers armed with a revolutionary way of seeing the universe. And so the model was complete, a breathtaking piece of theoretical physics. A geometric illusion born from staggering velocity and our own finite speed of light. It was an elegant, almost perfect explanation for a cosmic ghost story. But in science, a beautiful theory is merely a beautiful suggestion. An untested hypothesis, no matter how compelling, remains a fragile thing, a ghost in its own right, waiting for the harsh light of observation to give it substance or to watch it fade into nothing. To prove that these celestial cannons were truly firing matter at over 99% of light speed, to confirm that our equations were not just clever tricks of mathematics, but reflections of a profound physical reality. We had to move beyond the realm of pure thought. We had to build an eye sharp enough to see a single human hair from 100 miles away, an eye capable of resolving details in an object so distant that its light has been travelling for billions of years to reach us. The problem was to achieve that kind of resolution, that impossible clarity, we would need a telescope with a mirror the size of a planet. A preposterous, impossible dream. Or was it? Because we didn't build that telescope out of glass and steel. We built it out of the Earth itself. It is a technique with a deceptively simple name, Very Long Baseline Interferometry, or VLBI. Yet its execution represents one of the most astonishing technical ballets ever choreographed by humankind. Imagine for a moment not one telescope but dozens scattered across the globe, a dish in the arid deserts of Chile, another amidst the volcanic peaks of Hawaii, one in the green fields of Europe, another braving the frozen plains of the Antarctic, each a separate instrument, a lone soldier in the quest for knowledge, but through VLBI they become a single unified entity. Synchronized by atomic clocks of almost supernatural precision, these disparate observatories are instructed to stare at the exact same point in the deep cosmos at the exact same moment. They are not capturing an image. They are capturing something far more fundamental, the raw, untamed wavefront of ancient light itself. Each photon, having crossed an unimaginable abyss of space and time, arrives at these different locations at infinitesimally different moments, a delay of mere nanoseconds caused by the curvature and orientation of our planet. VLBI captures these delays. It records the precise arrival time of the light, the phase of its wave, the faintest whisper of a signal from the heart of a distant galaxy. Then this colossal flood of data, petabytes of it enough to fill entire libraries, is flown on hard drives to a central supercomputer, a digital brain known as a correlator. Here the true miracle occurs. The computer painstakingly compares the signals from every single telescope, aligning them in time, correcting for atmospheric distortion, for the wobble of the Earth's axis, for the planet's own rotation. In doing so, it doesn't just add the signals together, it uses the delays, the tiny timing differences between the observatories, to reconstruct the image that a single Earth-sized telescope would have seen. The distance between the telescopes becomes the diameter of our virtual mirror, and with that planet-spanning gaze, the ghost of superluminal motion was finally cornered. For the first time, we could see the jets not as blurry smudges or single points of light, but as the intricate, structured and violent phenomena they truly are. The images that slowly emerged from the digital fog were staggering. They resolved the cosmic blowtorch. We could see the jet's launching point, a searingly bright knot of plasma being squeezed and accelerated by the twisted magnetic fields just outside the black hole's event horizon. We followed its path outward, a brilliant spine of energy, a river of relativistic particles that remained tightly focused, a collimated beam, held together by a magnetic sheath like a cosmic superconductor. But it wasn't a smooth river. VLBI revealed it to be turbulent, clumpy and alive with violence. We could see bright knots of material, distinct blobs of plasma moving within the larger flow, and now, with the power of our global eye, we could track them. We could watch over months and years as a specific knot was ejected and travelled down the beam. We could measure its position with unprecedented accuracy. The results were the final, irrefutable proof. The knots were indeed moving at more than 99.9% the speed of light. The equations of special relativity held. The illusion of faster-than-light travel was confirmed not as a trick, but as a predictable consequence of that incredible velocity. The theory was no longer a ghost, it was now written in the language of light and data. Our Earth-sized eye had also revealed the jet's internal anatomy. We could discern the shock waves glowing where the supersonic flow slammed into itself or into the surrounding medium. These were the places where particles were being violently reaccelerated like surfers catching an impossibly energetic wave. Using polarized light, we could even map the magnetic fields themselves, the invisible scaffolding that shapes and guides the jet. We saw them twisted into a tight helix near the central engine, a cosmic spring being wound by the spinning black hole, before unfurling and stretching out for thousands of light years. It was a complete autopsy of a cosmic hurricane performed from a distance of millions of light years. We had stared into the heart of the storm and seen the machinery at work. The visual evidence was undeniable, a triumph of human ingenuity. But these images, as revolutionary as they were, only told part of the story. They showed us the structure, the form, the glowing plasma, but they couldn't fully capture the sheer unbridled fury of the engine itself. To do that, we needed to see the universe not in the gentle photons of radio waves, but in the most energetic light that can possibly exist. We needed to see it scream. There is a form of light so energetic it behaves less like a wave and more like a celestial bullet. A single photon of this light can carry more energy than 1 billion photons of visible light combined. This is the realm of gamma rays. They are not produced by the gentle heating of stars or the warm glow of dust. They are the unambiguous signature of nature's most extreme particle accelerators, the death cries of matter in the most violent conditions imaginable. Our atmosphere thankfully shields us from this cosmic radiation. So to see the gamma-ray sky, you must leave the Earth behind. And for over a decade, our eye in this brutally energetic sky has been the Fermi Gamma-Ray Space Telescope. Fermi doesn't use mirrors or lenses. You cannot focus a gamma ray. Instead, it is in essence a particle detector in space. When a gamma ray from deep space finally ends its journey, by striking one of Fermi's dense tungsten layers, it annihilates in a flash of pure energy, creating a cascade of secondary particles, electrons and their antimatter counterparts positrons. By tracking the paths of these newborn particles, scientists can reconstruct the energy and the original direction of the incoming gamma ray. It is the ultimate cosmic crime scene investigation, tracing the bullet back to the gun. When Fermi first opened its gamma ray eyes, it revealed a sky that was utterly alien. The familiar constellations were gone. The soft glow of the Milky Way was a faint backdrop. Instead, the sky was dominated by a few hundred pinpricks of ferocious, unrelenting light. These were the blazers, the very same active galactic nuclei we'd been studying, but seen from a terrifyingly unique perspective. A blazer is what you see when the galaxy's relativistic jet is aimed by chance directly at you. You are staring straight down the barrel of the cosmic cannon. What VLBI saw as a river of plasma seen from the side Fermi experienced as a blinding headlight. And the light from this headlight told us something profound about the physics happening inside. The gamma rays weren't coming from the base of the jet right next to the black hole. If they were, they would be so densely packed that they would annihilate each other long before they could escape. Instead, Fermi's data showed that the scream was loudest, much farther out, tens, even hundreds of light years down the beam. This was the smoking gun. It meant the jet itself was the accelerator. The central engine provides the raw material and the initial push, but the truly mind-boggling acceleration to near light speed happens within the jet's flow, in those violent shock fronts we glimpsed with our radio eyes. Here in these churning, chaotic regions, particles are trapped in a magnetic pinball machine. They are bounced back and forth across the shockwave, gaining a tremendous burst of energy with every single crossing. This process, a cosmic-scale version of what we do in our particle accelerators on Earth, kicks electrons to energies so high, their individual masses increase thousands of times over. These hyper-energetic electrons then radiate away their power in two ways, creating a symphony of light across the entire electromagnetic spectrum. First, as they spiral around the jet's magnetic field lines, they shed energy as synchrotron radiation, the very radio waves that our VLBI network so brilliantly captured. But then something even more dramatic occurs. These same electrons can collide with the lower energy synchrotron photons they themselves just created. In a process called inverse Compton, scattering the electron transfers a huge portion of its kinetic energy to the photon, boosting it from a simple radio wave into a high-energy X-ray, or a fearsome gamma ray. This is the scream Fermi hears. It is the echo of a particle being accelerated to its absolute limit. It is the physics of the universe at its most extreme laid bare. With Fermi, we could watch these blazers flicker and flare on timescales of mere hours. A sudden brightening in gamma rays told us that a new shockwave had formed a new batch of particles being energized. We could coordinate our observations, pointing our Earth-sized VLBI eye at the blazer at the exact moment Fermi saw it erupt. And we could see it. We could see a new bright knot emerging from the core, the very same knot responsible for the gamma ray fireworks. The evidence was woven together from the longest radio waves to the most energetic gamma rays. We had seen the jet's structure, we had heard its energetic scream, and the story they told was consistent. The case was closed. But a new, grander investigation was just beginning. Because a force this powerful doesn't exist in isolation. A storm of this magnitude doesn't just blow through the cosmos without leaving a trace. We had proven the hurricane was real. Now we had to ask, what did it do to the universe it inhabited? For eons, we imagined galaxies as serene island universes evolving in quiet solitude. We now know this picture is profoundly wrong. Galaxies are ecosystems. and at the heart of many lies a monster that shapes their destiny. The relativistic jet is not fired into an empty void. It must first tear its way out of its own host galaxy, a journey of thousands of light years, through a medium filled with gas dust and nascent star systems. This titanic struggle between the jet and its galactic home is known as cosmic feedback, and it is one of the most important forces in the evolution of the entire universe. The jet acts as both a destroyer and an architect. As this celestial blowtorch, trillions of times more powerful than our sun, carves through the interstellar medium, it creates a colossal shock wave. This wave can rampage through the delicate, cold molecular clouds where new stars are born. It heats them, shreds them, and blows them apart, effectively sterilizing the galaxy. The very engine that makes the galaxy's core shine can shut down star formation across its entire disk. This is negative feedback. It is the galaxy's own heart, acting as a cosmic thermostat, preventing it from growing too large too fast. We see the evidence for this galactic infanticide everywhere we look. The biggest, most massive galaxies in the universe, the ones with the most powerful jets, are almost all red and dead old, filled with aging stars and forming virtually no new ones. Their central monster has scoured them clean, but the story is more complex, for this cosmic force has a dual personality. Under the right conditions, that very same shockwave that can destroy a star-forming cloud can also create one. As the shock front expands, it can compress the surrounding gas, piling it up into dense knots and filaments. It can push the gas to a critical density where its own gravity takes over, causing it to collapse and ignite in a brilliant flash of new stellar birth. This is positive feedback. The jet's passage can trigger spectacular starbursts in its wake, like wildfires clearing a forest and allowing new seeds to sprout. The jet is a galactic-scale sculptor, carving away here, building up there, dictating the fate of billions of stars with its every move. But its influence extends far beyond the confines of a single galaxy. These jets are so powerful, they can punch entirely out of their host galaxy and travel for millions of light years into the vast, tenuous space between galaxies, the intergalactic medium. Here they perform their most crucial role as cosmic architects. They inflate immense bubbles or lobes of magnetized plasma visible to our X-ray and radio telescopes. These lobes, some larger than entire galaxies, are reservoirs of incredible energy. They heat the surrounding intergalactic gas, preventing it from cooling, and falling onto nearby galaxies, thus regulating the growth of entire galaxy clusters. They are the weather systems of the cosmos, and they are also the universe's grand recycling program. The matter fired out in these jets is not pristine hydrogen and helium from the Big Bang. It is material that was once part of stars which were torn apart by the black hole's gravity and swirled in the accretion disk. It is enriched with heavy elements, carbon, oxygen, iron, the very building blocks of planets and life. These jets are colossal cannons seeding the desolate intergalactic void with the raw materials needed for the next generation of galaxy stars and perhaps worlds like ours. Through the combined power of our greatest observatories, we have built a new understanding, one where the largest and smallest scales of the universe are intimately connected. The chaotic dance of matter around a singularity a few billion miles across dictates the evolution of a structure spanning millions of light years. From the intricate physics of a single electron spiraling in a magnetic field to the fate of an entire cluster of 1,000 galaxies, it is all one interconnected story. We have seen the phantom, we have measured its speed, we have heard it scream, and we have witnessed its power to shape worlds. And yet, as we stand here with this stunningly complete picture, we are also humbled. Because at the very base of the jet, in the first few light hours of its journey, in that crucible of extreme gravity and magnetism where it all begins, the details remain shrouded in mystery. The engine is confirmed, but its innermost workings are still a secret we have yet to steal from the universe. And so the paradox resolves itself not with a whisper, but with the roar of a space-time engine pushed to its absolute limit. The cosmic hurricane, that impossible swirl of gas moving faster than light, was never a violation of physics. It was an invitation to look deeper, to challenge our own perception, and to accept that the universe operates on a scale of such violence and grandeur that it must play tricks with light and time simply to be witnessed by our fledgling senses. We have journeyed from a single bewildering point of light in a telescope's eyepiece, a smudge of data that defied all logic, to the very edge of a gravitational abyss. We have stared into the maelstrom of an accretion disk, a celestial grinder where stars are shredded and matter is heated into a transcendent plasma, its final scream of energy painting an illusion across the heavens. The solution, when it arrived, felt less like a discovery and more like a remembrance of a fundamental truth we had learned a century ago, but had never seen demonstrated with such terrifying elegance. Einstein's universe is not a static stage. It is an active, pliable medium. Light, our ultimate cosmic messenger, does not travel in perfectly straight lines over these immense distances when gravity has warped the very fabric of the raceway. What we witnessed was a projection, a phantom on the cave wall of the cosmos. The gas itself, while moving at an unimaginable fraction of light speed, remains obediently within the laws of causality. But the light it emits caught in the geometric crossfire of its own motion, and our distant line of sight creates a breathtaking deception. It is a celestial magic trick, and by solving it we have not diminished the wonder, but deepened it immeasurably. We have replaced a simple impossibility with a complex, beautiful, and profoundly instructional truth about the nature of reality. This journey has been a testament to the scientific process itself, a perfect storm of observation skepticism and theoretical rigour. It began with the quiet dedication of astronomers cataloguing the sky, their patience rewarded with an anomaly so profound it bordered on heresy. Then came the theorists scribbling equations that danced on the edge of comprehension, seeking to reconcile the seemingly irreconcilable. They built models in supercomputers, virtual universes where they could birth a black hole, feed it gas and watch it ignite, hoping to replicate the ghost they had seen in the data. Every failed model, every dead end was not a defeat but a crucial step narrowing the path, eliminating possibilities until only the most extraordinary explanation remained. It's a process that mirrors our own evolution. In understanding the cosmos, a slow, painstaking climb out of the darkness of intuition and into the brilliant, often counterintuitive light of evidence. The cosmic hurricane, therefore, is more than just an exotic astrophysical phenomenon. It serves as a monumental anchor point for our understanding of the universe's most extreme physics. In its fury, we see the validation of concepts that for decades existed primarily on blackboards and in the minds of geniuses. General relativity is not just a theory about the gentle curve of starlight around our sun. Here it is a roaring, twisting, violent force that governs the final moments of all matter. In the glow of that superheated gas, we can almost feel the frame-dragging effect, the lens-through procession, where the black hole's colossal spin literally twists the fabric of space-time into a vortex, a gravitational gyroscope forcing everything in its vicinity to dance to its rhythm. This is not theoretical physics anymore. It is applied physics on a scale that beggars belief. Think of what this discovery truly means for our cosmic perspective. We are accustomed to thinking of the universe as ancient, vast, and largely empty, a place of serene, slow-moving galaxies and silent, twinkling stars. But the hurricane reveals the universe's other face, one of unimaginable ferocity. It shows us that at the heart of galaxies, including perhaps our own Milky Way in its distant past, there are engines of creation and destruction that dwarf anything we can conceive. These are the places where the fundamental forces of nature are pushed to their breaking points, where matter is converted to energy with an efficiency that makes our most advanced nuclear reactors look like primitive campfires. The accretion disk is a celestial blowtorch forging heavy elements and spewing them out into the interstellar medium, seeding the next generation of stars and planets. It is a lighthouse in the cosmic dark, its beams sweeping across eons visible from billions of light years away, a beacon signalling the presence of a monster. This revelation forces us to reconsider the very nature of observation. We as human beings are fundamentally Newtonian creatures. We evolved in a world of slow speeds, gentle curves, and solid objects. Our intuition is a finely tuned instrument for survival on a small rocky planet, but it is a profoundly unreliable guide in the relativistic universe. The cosmic hurricane is the ultimate lesson in humility. It tells us that what we see is not always what is there. It reminds us that our senses, and even the powerful instruments we build to extend them, are susceptible to the grand illusions woven by the interplay of light speed and gravity. To be a scientist, to be an explorer of the cosmos, is to cultivate a healthy distrust of the obvious. It is to learn to see the universe not as it appears to be, but as the mathematics and the evidence tell us it must be. This understanding did not arrive in a single flash of insight. It was built layer by generations of thinkers. It stands on the shoulders of Schwarzschild, who first found the mathematical possibility of a black hole hiding within Einstein's equations. It is indebted to the pioneering radio astronomers of the mid-20th century, who first detected the strange, powerful emissions from quasars, realizing they were seeing something far beyond ordinary stars. And it is a direct result of the global collaboration that created instruments like the Event Horizon Telescope, a planetary network of dishes synchronized with atomic clocks, working in perfect unison to create a virtual lens the size of the Earth itself. The image of that superluminal motion is a portrait painted by the entire human species, a testament to our collective unyielding curiosity. It is the product of our relentless desire to connect the dots, to find the pattern in the chaos, and to hear the story being whispered by the light from a forgotten age. Reflecting on this journey, we're forced to confront the sheer, unadulterated strangeness of our universe. We live our lives on a tranquil island of familiarity, shielded by a thin atmosphere and a gentle magnetic field. But beyond this sanctuary, the cosmos is a realm of phenomena so alien they strain the very limits of our language and imagination. There are neutron stars spinning 1,000 times a second, their surfaces composed of matter so dense a single spoonful would outweigh a mountain. There are magnetars with magnetic fields so powerful they could strip the information from every credit card on Earth from halfway to the moon. And there are the supermassive black holes, the gravitational hearts of darkness surrounded by their incandescent time-bending hurricanes. These are not curiosities or footnotes. They are fundamental components of the cosmic ecosystem. They are the architects of galactic structure, the regulators of star formation, the engines that have shaped the universe we inhabit today. Knowing they exist changes everything. It enriches our night sky, transforming it from a static canvas of stars into a dynamic living entity. When you look up now, you understand that hidden in the deep, dark spaces between those familiar constellations are these cauldrons of creation. You know that the universe is not just expanding, but churning. It is a place of constant, violent transformation, a cosmic ocean with tides and currents and storms that can rage for millions of years. Our observation of this single distant maelstrom has given us a new sense, a new way to perceive the hidden mechanics of the cosmos. We can now see the gravitational weather patterns, the interplay of inflow and outflow, the delicate and brutal balance that allows a galaxy to live and breathe. And yet, for all we have uncovered, the mysteries have only deepened the questions, multiplying with every answer. The hurricane, now understood, becomes a new tool, a new probe for exploring the even more profound enigma. It encircles the event horizon itself. What happens to the information that falls past that point of no return? How do these behemoths grow to be billions of times the mass of our Sun? Did they form from the collapse of colossal primordial stars, or did they grow from smaller seeds relentlessly merging and consuming over cosmic time? We have seen the storm, but we have yet to map the coastline of the abyss it borders. We have measured the phantom's speed, but we have yet to truly understand the nature of the singularity that powers the illusion. These are the questions that will drive the next generation of astrophysics. The future of this exploration is not just about building bigger telescopes, but smarter ones. We are entering an era of multi-messenger astronomy, where we no longer rely solely on light. Imagine combining the exquisitely sharp radio images of a cosmic hurricane with the faint trembling whispers of gravitational waves, ripples in space-time itself, generated by an object spiraling into that same black hole. Such a detection with an instrument like the planned Laser Interferometer Space Antenna, or LISA, would allow us to hear the soundtrack to the movie we are watching. It would be like feeling the tremor of a distant explosion moments after seeing the flash, a fundamentally new way to experience a cosmic event, providing a direct measure of the black hole's mass spin and the violent dynamics of its final moments. Future X-ray observatories like the Advanced Telescope for High-Energy Astrophysics or Athena will act as cosmic thermometers, taking the temperature of the gas in the accretion disk with unprecedented precision. They will be able to map the iron lines in the plasma spectral fingerprints that are stretched and warped by the intense gravity, allowing us to trace the flow of matter as it makes its final frantic orbits. We will be able to see the hotspots, the magnetic flares, the turbulent eddies within the hurricane, moving from a static picture to a dynamic evolving weather map of the black hole's immediate environment. We won't just know the illusion is there. We will see the physical engine that creates it moment by moment. Furthermore, our theoretical models will leap forward, powered by the next generation of supercomputers and the burgeoning field of artificial intelligence. AI algorithms will be able to sift through petabytes of observational data, identifying subtle patterns and correlations that a human mind could never detect. They will run simulations of such complexity that they become nearly indistinguishable from reality itself, evolving virtual universes to test our theories against the observational data from these new instruments. We will be able to model the intricate dance of magnetic fields within the accretion disk, understanding how they extract energy from the black hole's spin to launch those colossal, relativistic jets we see punching through entire galaxies. We will finally connect the hurricane at the center to the galactic scale consequences miles above the storm. The quest will also become more personal. With instruments like the Extremely Large Telescope and its contemporaries, we will gain the ability to probe the centers of nearby galaxies with startling clarity. We will hunt for the telltale signs of less dramatic, but no less important accretion events around the supermassive black hole in our own Milky Way Sagittarius A. We are searching for the echoes of our own galaxy's violent youth, seeking to understand the history of the gravitational monarch that governs our own cosmic home. The lessons learned from the distant furious hurricanes will be brought to bear on our own doorstep, helping us write the biography of the Milky Way. But perhaps the most profound impact of this journey is not what it tells us about the universe, but what it tells us about ourselves. In the face of such incomprehensible scale and power, it would be easy to feel small, insignificant, a fleeting accident in a cosmos that is indifferent to our existence. Yet the opposite is true. The story of the cosmic hurricane is a human story. It is the story of a species that, confined to a tiny world, dared to look out into the infinite and ask, why? It is a story of our insatiable curiosity, our refusal to accept a simple mystery, our relentless drive to dismantle the impossible and rebuild it as understanding. We are the part of the universe that has evolved to question itself. The carbon in our bodies, the iron in our blood were forged in the hearts of stars and perhaps flung across space by forces not unlike the ones we have just witnessed. In a very real sense, we are the cosmos made conscious. And the act of observing, of understanding a phenomenon like this is a deeply meaningful act. It is the universe through us coming to know its own spectacular and violent beauty. Every equation we solve, every photon we capture is a fulfillment of a potential that has lain dormant for billions of years. So as we conclude our journey, we are left not with an ending, but with a new beginning. The cosmic hurricane is no longer an anomaly that breaks the rules, but a signpost pointing the way toward a deeper, richer and far stranger reality than we ever dared to imagine. It stands as a permanent, glorious reminder that we are still in the early days of our exploration. There are more illusions to unravel, more monsters hiding in the dark, more fundamental truths waiting to be discovered. The universe is under no obligation to make sense to us, and in that fact lies its greatest allure. It constantly challenges us, pushes us, forces us to be smarter, more creative, and more humble. The quest for knowledge is a journey without a final destination, and the view along the way is, and always will be, absolutely magnificent.